Good morning, children. Today I am going to explain the concept of relations. Okay, so let us see the Cartesian product first. What is a Cartesian product? Here we are going to consider two sets. Set A, the elements are 1, 2 and 3. In the set B, the elements are P and Q. Now, Cartesian product is denoted by A cross B. It is read as A cross B. And in the Cartesian product, we will write the order pairs. How to write the order pairs? See, consider the first element of set A, okay, and the first element of set B. So we will write this pair 1p. This is the first element of the Cartesian product, 1p. Then 1q. Second element is 1q. 1p, 1q. Then 2p, 2q. So in this way we get the Cartesian product 2p, 2q, 3p, 3q. This is called as the Cartesian product A cross B. So A cross B is the Cartesian product. This is the simple concept. Now what is a relation? Here again this set are A and B, these are the two set. Then relation R, this is relation R from A to B, is a subset of the Cartesian product A cross B. So we can say that any subset of the Cartesian product A cross B is a relation. So you can consider any subset. Subset means if we write some elements of these sets or all the elements of these sets, then it will be a subset. For example, this is the set R. In this set I have written the elements 1p, then 2p and 3p. So this set is the subset of the Cartesian product A cross B, and hence it is a relation. So the concept of relation is simple, that any subset of the Cartesian product will be a relation. We can draw the arrow diagram also like this. So this is the relation R, set R. In this set the elements are 1p, 2p and 3p. So these are the set A and set B. This is called as the arrow diagram. So in this arrow diagram we can write the elements. In the set A the elements are 1, 2 and 3. Okay. In the set B the elements are P and Q. Now 1 is related to P, 2 is related to P, 3 is related to P. Okay. So by this arrow we can show this relation. So this is the simple diagrammatic representation of the relation of two sets. Okay. And here there is the concept of domain and the range. Now in this domain of the set R, we'll write the elements in the set A. So elements in the set A are 1, 2, 3, which are related to the set B. So we'll write those elements only. So all the elements are related in the elements of set B. Therefore, the domain is 1, 2, 3. And the range. Here, the range, in this range, we'll write the elements which are related to the elements in the set A. Okay. So here the domain will be set P only. Element of this element P only. Okay. So set in which the element is P. This is the range. And set B, all the elements of the set B is called as the codomain. Okay. So there is a difference between the range and codomain. In the range we will write only those elements which are related. And in the codomain we have to write all the elements of the set B. Okay. In the second example, in this set R, this is the relation. I have considered two elements 1p and 2p only. So this is also the subset of that Cartesian product, and hence it is the relation. 1 is related to P, 2 is related to P. Here what is the domain? In the domain set we will write the elements 1 and 2 only, because they have the image in the set B. Okay, this is set A, this is set P. So P is called as the image of 1, Q is called as the image of 2, okay, and 2 is called the pre-image of Q, 1 is called the pre-image of P. And what is the range? Here the range is P and Q, and domain is also P and Q, so here we can say that the domain is equals to range. Okay, so this is the simple concept of relation. Now let us see the types of relation. Okay, first type is 1-1 relation. Simple concept of 1-1 relation is that 1 is related to only one element of set B. Each element of this set A is related to one and only one element of set B is the 1-1 relation, or we can say that this element in the set B has only unique image, a unique pre-image in the set A. Okay, so this relation is called as 1-1 relation. 1 is related to 1, 2 is related to 2, 3 is related to 3. So this relation is called as 1-1 relation. Okay, the elements in the set B should not have the same pre-image in the set A. Okay, so each element has unique image in the set B. This relation is called as 1-1 relation. Okay, here we can write that relation, we can represent that relation as y is equals to x. Y are the elements in the set B and x in the set elements of the set A. So we can relate the elements as y is equals to x. Here the domain is 1, 2, 3 and the range is 1, 2, 3. Codomain is 1, 2, 3, 4. Understood? This relation is called as a 1-1 relation. Then second type of relation is many-one relation. Many-one relation means more than one element of set A have the image in the set B. Okay, same image in the set B. So -1 is related to 1. 1 is also related to 1. So image of -1 is 1, image of 1 is 1, image of -2 is 4, image of 2 is also 4. So more than one elements in the set A are related to the same image, same element in the set B. This is many-one relation. So many elements of set A are related to the same one element of the set B. Here we can generalize this as y is equals to x square. These are y, these are x. So y is equals to x square. -1 square is 1, 1 square is 1. Okay, so in this way we can write the relation. Then domain. Here what is the domain? -1, 1, -2, 2. These are the pre-images, and the set of pre-images is called as the domain. Then set of images is the range. Range is 1 and 4. Codomain is also 1, 4. Then the third type is one-many relation. One-many relation means one element of set A is related to more than one element in the set B. So this one element of the set A is related to 2, 3 and 4, more than one element in the set B. So one has image 2, 3 and 4. These are three images of the one element of set A. Here 2 also have the images. Image of 2 is 3 as well as 4. Okay, we can generalize the relation as y is greater than x, and here the domain is 1 and 2. Then range is 2, 3 and 4. We will not include 1 because 1, this element does not have any pre-image in the set A. So codomain In this codomain, we will include 1, 2, 3 and 4. Okay, and the next is onto relation and into relation. Onto relation. In this onto relation, if the range and the codomain are same, then that relation is called as onto relation. Here observe the sets carefully. In the set A element are 5, 7, 9. In the set B elements are 8, 10 and 12. 5 is related to 8, 7 is related to 10, 9 is related to 12. We can generalize it as y is equals to x plus 3. So the domain is 5, 7, 9. Range is 8, 10 and 12. So we can write the range. It is 8, 10 and 12. And the codomain is also 8, 10 and 12. There is no element in the set B which does not have any pre-image in the set A. That is, range and codomain are equal set. So when range and codomain are equal, the relation is onto relation. Okay, and when range is the subset of codomain, range is subset of codomain, or we can say that when range, there is some extra element in the codomain which is not in the range. In that case, the relation becomes into relation. Therefore, this relation is one many relation as well as into relation, because there is this extra element, one element in the codomain in the set B which does not have any pre-image in the set A. Understood the types of relation?